Okay, looks like we're live. So today we're gonna be working on the specs. My name is Mark, and basically, we're working on interop. The specs they got out of date. They don't make a lot of sense. So I'm literally just gonna work on the specs and talk through what we're doing because working in the public is important, and you know figured it would be a good use of time to block off. Now nobody can distract me on Slack or Discord. So we've got this website specs.optimism.io. It's these markdown files. This is kind of the overview for interop. So let's see if this is out of date. The ability for a blockchain to easily read the state of another blockchain is called interoperability. Low latency interoperability allows for horizontally scalable blockchains, a key feature of the superchain. Yeah, I think that's true. I think we want to say, interoperability already exists today. You just have to withdraw from one L2 and then deposit into another L2. So the ability for a blockchain to easily read the state of another blockchain is called interoperability. The goal of OP stack native interop is to enable we want to say interoperability exists. It is possible to interop is possible today. I don't want to say something that goes out of date. It is possible to interop is possible between, say, relatively trustless interop is possible between rollups by using L1 Ethereum as a hub. The message is, withdrawn from one chain to L1 and then deposited to another chain. The goal of OpenStack native interop is to enable cross-chain messaging at a much lower latency than going through L1. Low latency interoperability allows for a horizontally scalable blockchain network. Cool. So we just kind of rewrote that. When I got a new laptop, I didn't copy over my vimRC, so now I'm using cursor. It happened. Let's see. Is this clear? They have encountered an error with my Anthropic key. Well, I guess I'm not going to be using AI today to do this. Such is life. I don't even know what I'm doing because Vim's great, but I need to fix my Vim RC. I'm sorry, Clabby. All right, so we fixed up the intro. Let's see, a total of 2 transactions are required to complete a cross-chain message. First transaction is submitted to the source chain and emits an event. So emits a log. Maybe in here we want to add the term log. So a log is, it's like the Ethereum consensus object created by the log opcodes. Event. The solidity. Like an event is just kind of like the way that Solidity, uses logs. So an event is the Solidity representation of a log. Perfect. All right, so a total of 2 transactions are required to complete a cross-chain message. Let me just check in on the chat. We got some people in here. Hello. Hello, Don Bill. Thanks for joining. All right, so let's keep doing the specs. So I'm looking for people that, want to help me. So if you have any ideas, want to help, get some sentences in the specs, help me out. Maybe next time I'll have some AI. Can have AI rewrite the specs. Because, I don't know if the hype is real or not. 2 or 3 years. Maybe it is, maybe it's not. All I know is that I'm happy I pivoted to management before AI replaced all the engineering jobs. All right, so let's see. A total of 2 transactions are required to complete a cross-chain message. First transaction is submitted to the source chain and emits a log. First transaction is submitted to the source chain, and any log that is emitted can be used as an initiating message. that can be consumed on a destination chain. All right. If anybody has some good Vim tips, let me know. I know this isn't NeoVim, but I feel like a ninja just zooming around. All right. So, a total of 2 transactions are required to complete a cross-chain message. The first transaction is submitted to the source chain, and any log that is emitted can be used as the initiating message that can be consumed on a destination chain. The second transaction is submitted to the destination chain and includes the initiating message as well as the identifier that uniquely points to the initiating message. I don't think that reads well. Chain's fork choice rule will reorg out any blocks that contain an executing message that is not valid, meaning that the identifier actually points to the initiating message that was passed into the remote chain. This means the block builder should only include an executing message if they have already checked its validity. The proof system is able to check the validity of all executing messages, ensuring that withdrawals the proof system is only useful for withdrawals. Finality is when the data is posted, not when the proof system finalizes. There's a difference between inputs and outputs. Find the essay. Okay, so chain's fork choice rule will reorg out any blocks that contain an executing message that is not valid. A valid executing message means that the identifier correctly references the initiating its initiating message. This means that the block builder should only include an executing message if they have checked its validity. Okay, so the proof system is able to check the validity of all executing messages. Okay, I think that this is good. We can keep going. All right. So what needs some So let's talk about the sequencer. I think the sequencer page needs a little bit of love. All right, so sequencer policy. All right, so let's add an overview section. Overview. So sequencer. I think let's move this over here. People are going to get so confused. What's a sequencer? What's a builder? What's a searcher? What's a solver? Everything was so much more simple when we just had miners. Then flashbots had to come along. We love flashbots though. All right, so the term block builder is used interchangeably with the term sequencer for the purposes of this document, right? So, okay, the big thing about the sequencer is like interop, interop adds new validity rules to the block. That the sequencer must follow. Basically, every executing message must be valid. A block that includes an invalid executing message. Block that includes an invalid executing message will be reorged out of the canonical chain. And replaced with a deposits on the block. Okay, so I need to like clean that up, but sequencer policy is the process of like sequencer policy represents the set of ways that a sequencer may act that are not constrained by consensus, right? Like, so policy. What is an example of a policy? It's like the P2P limit on the size of transactions, right? Like you can include a transaction arbitrarily large up to like the block gas size limit. If it's like, I forgot how much gas it is for a piece of call data, right? But consensus allows very large transactions, much larger than what are allowed to be gossiped around the P2P network. So this is a policy by nodes that is set to prevent like some sort of spam, where very large transactions are just sent around. It's more of like a DOS. So sequencer policy represents the set of ways that a sequencer may act that are not constrained by consensus. I like this paragraph, but like OP stack interop leverages sequencer policy to reduce synchrony assumptions between chains. The sequencer of one chain, sequencer has the right to choose. Sequencer has the right to choose the safety level. Safety. The sequencer has the right to choose the safety level of initiating messages that it includes in blocks. If it sequencer policy represents a set of ways that a sequencer may act that are not concerned with consensus. If it includes, unsafe messages, what's up, C? Okay, so basically, like, if the sequencer includes unsafe messages, it has this risk of the like contingent reorgs. So if it includes unsafe messages, I'm not sure how to word this. I'll come back to this. But I do want to come back over here and say something about contingent reorgs. All right, so the fork choice rule basically, like, the integrity of a message is guaranteed at the application layer because due to the reorgs, the integrity of a message is guaranteed at the application layer without the need for any sort of confirmation depth because of the reorgs. All contingent reorgs. All right, I want to get this in there. The integrity of the message is guaranteed at the application layer without the need for any sort of confirmation depth because the fork choice enforces this invariant. Chains may all right, I think I'll come back to that. But I think that's good. Cool. Sequencer policy is the process of optimistically enacting rules outside of consensus. It's not necessarily only optimistically, but it can be optimistically. And the choices can then be, I think, just a little bit. Is this update based on the chats going on around message passing standards? Yeah, good question. I think so. I mean, the specs need polishing. I'm here to polish the specs. We've learned a lot in, the year since we've been working on this. It's way too big of a release. Oh my God. I thought we were never gonna wait a whole year before releasing something ever again since Bedrock, but here we are doing a project that's taken a year to release. Oh, blockchains. All right, so I think I'm gonna say let's just get to the point. Sequencer policy is utilized to enable cross-chain it's 2 words. Cross-chain messaging without adding strict synchrony assumptions to the article. If the sequencer is not, if this is this database. Okay, we already have dependency confirmations, pre-confirmations, pseudocode. Okay. Block building. Just say like it is now required that a block builder fully executes a transaction and validates any executing messages that it may produce before knowing that the transaction is valid. Right, so in Ethereum, historically, the idea is to make it so that you don't need to execute a transaction if it's valid. You can just look up its nonce and you can look up its balance and know the base fee from the block header. So like the reverting transactions can be included. If they have the right nonce, and they can pay the fee. But now with interop, we're coupling the execution to the validity through this log that gets created. So it does create a little bit of a DOS opportunity, but that's just an engineering problem that we can solve. So don't be scared. Okay. It is now required that a block builder fully executes transaction and validates any executing messages that it may produce before knowing that the transaction is valid. This adds a denial of service possibility for the block builder because because a transaction may consume a lot of resources during the block building process. Okay, dependency confirmations. If the sequencer's view of a remote chain lags from the tip, will not impact the overall liveness of the network. It will only impact the liveness of inbound cross-chain messages from that remote chain. I think that's like a good way to put it. Top Shots Eve. What's up? Nice to meet you. We're just writing some specs, so help me write some specs. All right. So basically, the problem is we don't want reorgs if one chain, falls out of sync. So maybe if there was a strict synchrony assumption that could be possible to could result in redness or safety failures when one chain, when any sequencer cluster falls behind the tip of any remote chain. Yeah, I think that's good. All right, see, thanks for coming to say hi. Okay, so I think that's good there. Block building. It is not required that a block builder fully executes a transaction and validates any executed messages. It is generally accepted that block builders can build solutions, can be heavy, sophisticated actors that can build solutions for this sort of problem. Okay, so interop adds new validity rules to the block. New validity rules are added to blocks that the sequencer must follow if the rules are not followed, then the sequencer risks producing reorgs producing empty blocks, and we will gain the chain. Okay, I think that's good. I think I need a canonical definition of valid executing message. I think I'm renaming this to safety levels. Let's move this up here. And so the sequencer policy. Let's see. Yo, DC Builder. Shout out to DC Builder. DC Builder. Thanks for saying hi. If you have something that you want to get into the specs, shout it out. Trying to get lots of people contributing. All right, so sequencer overview. Let's get rid of that. All right, sequencer overview, block building, sequencer policy. Safety levels are a section inside of sequencer policy. The sequencer may include an executing message in a block. Let's say the sequencer may include an executing message with any level of I just need to check to make sure I don't have any meetings coming up. Oh no, I've got a meeting in about a half hour, but that's okay. We can keep working on the specs. I think I need to AI supercharge this next time. Okay, so the sequencer may include an executing message with any level of confirmation safety, including pre-confirmation, including cross-chain messages based on pre-confirmation levels of security, result in lower latency messaging at a higher risk of an invalid block being produced. So the sequencer may apply different levels of sequencer may apply different levels of safe, may, it's depending on the chain, but that doesn't really make sense. The sequencer may apply different levels of security may require different levels of security depending on the source chain, depending on the source chain. If the initiating message is um, if the block containing the initiating message is considered safe, no additional trust assumptions are assumed. The only time that additional trust assumptions are added is when the when an initiating message from an unsafe block is consumed. All right, so confirmation levels. Let's delete this. Should revalidate. Before a block is published. So I'll delete that. I think I want to have something in here about, like, you know, the ordering of transactions. Ordering of transactions in a block is considered policy. Consensus dictates that all of the transactions in a block are valid. I mean, there's like an edge case here because it's like the nonces can't be out of order, but okay. When the sequencer okay. So now we are talking about pre-confirmations. think that shreds are a really cool idea, but I don't think that we should have it in the specs right now. It's a little bit, um, we just don't have it. Let's just like add a section on, shared sequencing. And then what we can do is, let's take this, put this written right there, put here. Okay, so it is possible to build a shared sequencer on top of OP stuff. A shared sequencer can be built on top of OP stack interop if if this can enable we love our buzzwords, synchronous composability, with transactions that execute between multiple chains at the same timestamp. All right. Pre-confirmations. The block builder can include external messages that personalization. Let's delete this. Delete. Pre-confirmation is one word. I think so. All right. Unfortunately, I need to call it, but we did a good job. We got some specs rewritten today. Oops. Yeah, a little bit of rewriting. This is, we got a lot more to do. Gonna keep rewriting these. Next time I'll be back, have some AI power. But I gotta go to a meeting now. Gotta do some meetings.